Section 10.3, Areas of Regular Polygons. Our objective is to find the area of a regular polygon. Remember that a regular polygon has exactly the same length sides. If you have 6 sides, all the sides are the same. If you have 8 sides, all the sides are the same, so on. So if you split those polygons into triangles, all of those triangles will be the same as well. The radius of a regular polygon is in the light blue. If you're looking at the picture, it's the light blue halfway across. And normally polygons don't have the circle around it, but to figure out, what that radius length looks like, they put a circle around it and then show that as a radius, because that kind of helps you to imagine where it would be on a polygon. So it's from the center to a vertex. The apothem is basically the height of one of the triangles. So it's kind of in a 2D versus a 3D spot. So the apothem is the height of one of those triangles, not all of them at the same time. And also the center is, of course, the point in the middle. Problem number 1, the figure is a regular pentagon, which is 5 sides with radii and apothem drawn. What's the measure of each numbered angle? So when you think about this one, the first thing you have to do is figure out how many degrees is angle 1. So to do that, you're going to draw a circle kind of around that vertex. And remember, circles have 360 degrees. So for angle 1, we're going to take 360, and we're going to divide it by the number of triangles that there are, or the number of sides that there are. So a pentagon, remember, has 5 sides. And if you don't remember all of those, check out the book for pentagon, hexagon, decagon, dodecagon, so that you remember those for these types of questions. So 360 divided by 5, which is 72 degrees. So now we're going to focus on angle 2. So if all of this is 72 degrees, how much would that part be? Well, that would be half of it. So we're going to take our 72 degrees and divide that in half. So each angle is 36, or each small triangle angle. So for the last one, I'm going to break this out of there. I'll change colors quick. So we have this right triangle here. This angle right there is 36. So we're looking at angles of a triangle add up to 180. So 180 minus 90 minus 36 would be 54. So angle 3, again, 54 degrees. And you'll have to do that from time to time to find the part that you may need to find the area of the polygon. Looking at page 630, at the top, postulate 10.1, if 2 figures are congruent, then their areas are equal. So we pretty much knew that already, or you could think of that in your head. It's kind of a automatic postulate, so to speak. Theorem 10.6, make sure that you write these formulas down. This is the one that the book gives. This is the one that the book gives above, kind of in paragraph form. So there's actually 2 ways to find these, one by just common sense and the other by formula. The common sense one is an area of one triangle is half times base times height, and then you would multiply by the number of triangles that there are. This is the way that I learned. In the book, they're going 1/2 times A. Remember, A is apothem, and then P is the perimeter around the whole figure. So both equally, easy, so to speak. You can pick whichever one that you want to use. So let's go to problem 2. What is the area of the regular decagon? So I'm going to do this 2 different ways for you, just so you can see each of those formulas above. The first one I'm going to do is the way that I learned. So I'm going to draw a triangle in here. And we're looking at finding the area of one triangle. Base is 8. Height, this time, they gave us is 12.3, and that one got covered up by my purple line there. So the area of one triangle is 1/2 times 8 times 12.3. So 4 times 12.3 is 49.2. And then if you take it times the number of triangles, and this time a decagon has 10 sides, so we're going to multiply this by 10. So the total area of this decagon is 492, and all area questions you'll label squared, so inches squared. Now, what do you need to show? Pretty much all of this. Method number 2. By formula, area equals 1/2 A times P. So the apothem this time is the height of one of the triangles, which is 12.3. The perimeter, I'm going to do that off to the side, is the distance around the whole thing. Well, if each of the sides is 8, and we have 10 sides, the perimeter would be 80. So we can put that in there. Well, half of 80 is 40, and 40 times 12.3 is also 492. Okay, so on this one you would need these things along with that somewhere else. You could put 8 times 10 in the parentheses for the perimeter as well. If you wanted to instead replace this with 8 times 10, that would work and you wouldn't have to have that thing off to the side. So let's do one more. This one is a little bit harder because it just gives you a description. It doesn't give you a picture or anything like that. So you would have to place everything that they're talking about in the picture. So a honeycomb is made up of a regular hexagonal cells. Hexagons are 6 sides. So let's do one of those. 1, 2, 3, 4, 5, and 6. Center in the middle. I'm just going to do one of the triangles. The length of the side is 3 millimeters. What is the area of one of these cells? So the area of the whole thing. So first of all, we do not have the height, but we do have the base. So if you're going, and I'm going to do this twice, you would only need to do this once. So step number 1, one triangle times 6. So area equals 1/2 times the base, which is 3, times the height we do not know. So what we need to do is break this down further. So let's find the area of one of these. Remember, this is found by taking 360 degrees divided by 6, which would be 60, and then you have to half it again to get that angle. So here's the triangle that we are now kind of focusing on. It would be 30 at the top. And again, we're taking half of that triangle, so the base would be 1.5. So to get that, you would divide 3 by 2. So we have a right triangle. We're going to use trig, so remember our definitions. SOHCAHTOA. Do not use law of sines and law of cosines because we know that this is a right triangle and just using basic trig is easier. So what we're looking for is the height or the apothem, so to speak. So this one right here would be the opposite side. This one actually is the adjacent, so I'll leave it like that. So you're looking at tangent 30 equals 1.5 over A. Now this is one of those that the A would get multiplied over, and then you'd have to divide by the tangent of 30. Okay, so here's what it looks like. A tangent 30 equals 1.5, and then you'd have to divide by the tangent of 30. So A is 1.5 divided by tangent 30. Do not round quite yet, so don't do 2.6. What I'm looking at is 2.598. Go about 3 places out. You can round at the end to 1 decimal place. So our height is 2.598. And then we're going to turn around and multiply by the number of triangles, which is 6. So 1.5 times 2.598 times 6, 23.4. And this would be millimeters squared. And you would also need this and that. Okay, or you could put an arrow up, I guess. For the second method, we're going to do area equals 1/2 A times P. Well, 1/2, the A happens to be 2.598 because we just found that a second ago. Okay, so this would still apply. You'd still have to show both of those. And the perimeter this time is 3 times 6. So each side is 3. We have 6 triangles, so that would be 18. So you could put 3 times 6 there, or you could put just an 18 there, and then you would multiply to get your answer. Again, it is 1/2 times 2.598 times 3 times 6, which is 23.4 millimeters squared. Exactly the same answer as we got last time. Notice when you compare them like this, we're doing exactly the same thing. This part right here actually gets you the perimeter. Okay, so that's basically the difference. Is you don't have to remember the formula, you can get it either way, but you choose what you would like to do. You would have to use trig sometimes to find those missing parts. Make sure you're careful about your placement of your angles, and your calculating of your first angle is really the main part that you would get wrong, if anything. So do not round until 1 decimal place until the end. If there's more, take it to 2 or 3 places and then you'll be more exact. Many of you that got some wrong on the test, you rounded way too soon. So don't round off, because if you were actually working on a project for someone that you had to make something to fit, you wouldn't make it to fit because you rounded too soon. So good luck, and ask questions on Monday if you have them.